Okay, the gravitational potential energy questions. First set was on page 250, and I asked you to do 27 and 29. I purposely skipped number 28. 27 says a frame picture is to be hung on the wall and is lifted vertically through a distance of 2 meters. So that's my change in height, 2 meters. It starts on the ground, it goes up 2 meters. Picture has a mass of 4.45 kilograms. What is the gravitational potential energy with respect to the ground? So it's saying like the initial is 0 and the final is 2 meters. So you're looking for the change in gravitational potential energy, or you can just call it EG. mg, if you called it delta change, it'll be delta H. And so it's equal to 4.45 kilograms times 9.81 meters per second squared times 2 meters. And when you do this, you should get an EG of 87.31 joules, I believe. Yeah. Okay. Number 29. 28 I skipped because you needed to know the mass of water, and it gets complicated, the density, so you don't need to know it. Oops. So 29, like I was saying, is how high, so you're looking for H final or a delta H. How high would you have to raise a 0.3 kilogram, so M is 0.3 kilograms, baseball in order to give it 12 joules of gravitational potential energy? So EG is 12 joules. So really EF or delta H, because you're going to raise it and that's going to be its change in height. So EG or delta EG is equal to mg delta H. And so you're looking for this delta H EG over mg. So 12 joules over 0.3 kilograms times 9.81 meters per second squared. And when you do this, you should get an H of 4.08 meters. Okay, so that was 29. Flip the page to number 50, page 254. And here I think I asked you to do 30 to 33. So number 30. A student lifts her 2.2 kilogram pile of textbooks, so M is 2.2 kilograms, into her locker from where they rest on the ground. She must do 25 joules of work in order to lift them. So 25 joules of work, and she's lifting them. And so that means the work done will be equal to the change in gravitational potential energy, right? If she was speeding something up, then the work done would be equal to the change in kinetic energy. But here she's lifting them, so it's equal to the change in gravitational potential energy. And it wants to know, calculate the height that the student must lift the book. So again, I'm going to say that's either delta H or HF that you're looking for. And maybe I'm confusing you when I'm saying delta or final. But it's because if they start on the ground, right? And then, so then initial height is 0. And you lift them to some height up here, final height. Well, then delta H is just, delta anything is always final minus initial. But the initial, oops, it should be initial height, not initial energy. But the initial height was 0. And so if the initial height is 0, then this term goes, and so delta H is equal to H final. So that's what I was meaning up here when I was saying you could call it either one. And the same with energy. Delta energy is equal to the final energy minus the initial. But if the initial is 0, which it would be down here because the height is 0, this goes to 0, so the change in energy is just equal to the final. Okay, so that's why I'm kind of like in this case, and it's often true for EG, the delta and the final are the same because the initial is 0. So in this case, we have delta EG, and we have our M, and we're looking for our delta H. So delta H is going to be equal to delta EG divided by mg. So 25 joules divided by 2.2 kilograms times 9.81 meters per second squared. And when you do that, you get a delta H of 1.158 meters. Okay, so that's how high you need to lift them. Number 31 says a 46 kilogram child cycles up a large hill, so the mass is 46 kilograms, cycles up a large hill to a point that is a vertical distance of 5.52 meters. So your height, I think it's 25 meters. And again, that could be your delta or your final, because we're assuming your initial is 0, because it's 5.5 meters above the starting point. Find the change in the child's gravitational potential energy. So if we call this delta H, then we're looking for delta Eg, it's equal to mg delta H. 46 kilograms, 9.81 meters per second squared, times 5.25 meters. And you get a delta Eg of 2,369.12 joules. Okay, part B says, what's the amount of work done by the child against gravity? Well, remember, work done is equal to the change in energy. In this case, change in gravitational potential energy, because they said work done against gravity. And so part B is your part A's answer. Work done and change in energy will be the same thing. So 2,369.2 joules. Number 32 says a 2.5 kilogram pendulum, so mass 2.5 kgs, is raised vertically 65.2 centimeters. So delta H, 65.2 centimeters, which will be equal to 0.652 meters. From its rest position, find the gravitational potential energy. So again, delta Eg, and remember that's final minus initial, but initial would be 0. So it'll be mg delta H. It'll be 2.5 kilograms times 9.81 meters per second squared times 0.652 meters. And when you do this, you should get a delta Eg to be, did I do the right question? Find the gravitational potential. I did, okay. You should get it to be 15.99 joules, I believe. Okay, and the last one, number 33. And again, I skipped 34 just because it was a little weird wording. Roller coaster lifts a passenger up a vertical height of 39.4 meters. So delta H is 39.4 meters. From its starting position, find the change in gravitational potential energy if the mass of the train and its passengers is 3.9 times 10 to the third kilograms. And so you're just doing change in gravitational potential energy is equal to mg delta H. So 3.900 kgs times 9.81 meters per second squared times 39.4 meters. And when you do this, you should get a gravitational potential energy to be 1.507 times 10 to the 6th joules. Oops, forgot to box that one. I have to box this one. Okay, so they were all your homework questions.